Assalamualaikum and good days. Today I will present about our first project for applied physics. We choose freefall experiment for our topic. First, I will introduce our group members. My name is Muhammad Hafizuddin bin Hamzah, BE1303. I am from section 1. Next, Farisha Azra binti Ahmad Tarmizi, TE21007. She is also from section 1. Then Muhammad Iqwan Hakimi bin Kamaruzaman, TE21037, is also from section 1. And final member is Siti, Noor, Absarina, Rohayu, binti Ahmad, Badri, TE21044. She is from section 2. Next, I will talk about the introduction for our project. Free fall occurs when air resistance is ignored. The object can fall freely and accelerate at a constant rate gravity. Gravity can be described as a force that causes two particles to be pulled towards each other, and that force pulls an object towards the center of the earth. Next, as long as the object is close to the surface of the earth, then the force exerted by gravity can be considered constant. Gravity is the only force acting on an object with the object force. Next, I will talk about theory for our project. When a body falls in the gravitational field of the Earth from a head to the ground, it experiences a constant acceleration as long as the falling distance is small and friction can be neglected. This motion is called free fall. If the body starts at time 0 with the initial velocity is equal to 0, the distance it covers in the time is h equal to 1 over 2 gt squared. Thus, the free fall is an example of a uniformly accelerated motion. In the experiment, the free fall is an example of a uniformly accelerated motion. The free fall happens when a stapler pin box is dropped from diverse points on the statue such that there is a variety in height values. Due to its gravitational force, F equal to m times g. Time measurement is started when the box is falls downward in a uniformly accelerated motion, having covered the falling distance. The box falls onto the book and stops the measurement at the falling time. The measuring results for various falling distance as the box is at the beginning of the time measurement can be used to determine the acceleration of gravity. So that this is the apparatus that we use to conduct our free fall experiment. First is measuring tape. Second is stopwatch from smartphone. Next is pencil for mark and marker pen for mark the height. And the object we use to fall down is stapler pin box. And the final apparatus is book. Now I will talk about how we carrying out the experiment. This is the first step. First, we measure the falling distance using a tape measure. As you can see, there is a video here. Okay. Next, the second step is we mark the falling distance ranging from 5 cm to 100 cm. Then the step is we drop the stapler pin box at a height of 100 cm and record the time taken for the box to fall onto the book using a stopwatch. final step is we repeat the process until a height of 5 cm. Now is results and discussion for our project. First, we plot the graph displacement H versus E. Second, fill in the table with the square of the falling time and plot graph H versus T square. And then explain why we have to convert it into T square. Third, from the graph, determine the magnitude of the gravity by manipulating the equation given in the theory section. Please show the alteration of equation until you got the equation of gravity. Next is the comment about our graph and the value of the gravity that we get. Fill in the last column with the calculated value of G. There is a linear graph for both graphs based on the graph that I showed. The first graph depicts H versus T, while the second depicts H versus T squared. The value of gravity in the graph is increased in some places and decreased in others, indicating that the value is not decreasing in order. Next, I will discuss on how we can improve this experiment in order to get a better result. The results obtained during the experiment may not be completely accurate due to some errors. The error could be caused by a number of factors. First and foremost, the object we use is released unevenly, causing it to sway when it falls. It has already begun to sway before it begins to fall, but this swaying becomes more frequent as it falls due to the presence of air resistance. Perhaps we should decide on a suitable location for this experiment in order to improve it. Because according to the video, the experiment was carried out in a house. Because the fan was not turned off during the experiment, the error was caused by wind resistance in the house. Because of air resistance, also known as aerodynamic drag, the data we can see fluctuates quite a bit. If we can reduce the drag, we will conduct a real experiment. So, if we conduct the experiment in the proper location, we can obtain better results. Furthermore, the experiment's readings were not repeated. To ensure that the readings taken are consistent, we need to perform experiments 2 or 3 times to ensure that the data we obtain are accurate and precise. Next is what are the precaution actions that we can take during this session. There are some precautions that must be taken during this experiment, such as ensuring that the length we measure for each distance between one point and another is the same and accurate. This is due to the fact that varying the distance affects the time it takes for the stapler mini box to reach the floor. Gravity decreases with increasing distance. Furthermore, we must ensure that the experimental area is not influenced by external factors such as a wind, so that the experimental results are unaffected. If there are no external factors influencing the fall, such as air friction, the value of the acceleration of gravity does not depend on the shape and mass of the falling object. To avoid air friction, which will affect the acceleration of the stapler mini box, the experiment can be carried out in an airtight environment, such as a vacuum. Furthermore, when taking readings, the eyes should be parallel to the measurements to be read to avoid parallax errors. Finally, we come to the conclusion. According to the experiments and results we received, it can be concluded that the strength of the gravitational field is constant in all cases of free fall. This is because the height from which the object is dropped and the time of the fall do not affect its acceleration. By comparing the value of acceleration obtained with a constant value, we'll be able to take into account errors that occur while performing experiments. Therefore, we can conclude that acceleration due to gravity is 9.81 meter per second square. Thank you for your attention. That's all from me. Assalamualaikum.